Hey, so welcome back, and this is another daily code problem. So today it was called valid parentheses. So this is actually a very popular question. It has over 20,000 different upvotes here. And so it's an easy level problem that I was actually asked in an interview once. And so you're given a string and you want to return a Boolean. And all that you want to do is return true if this string is valid. Now, what makes up a valid string is that you're given a set of parentheses here, and they're either open parentheses or closing ones. And there's the three different kind of parentheses or bracket types. And you just want to make sure that for every open parentheses, there's a corresponding closing one, but you want them to appear in the right order. And so say if you're given an open parentheses here, you want a matching closing one. But let's say it's a kind of circular opening one and then a square one, then you want the closing brackets to appear in the reverse order. So you'd have a square closing one and then a circular one. But let's say that you have a kind of circular opening one and then two closing ones. You would want to return false in this case because you need it to be kind of mirrored across the middle here where you want them to be matching. So you want this kind of another opening bracket here. All right, and that's basically the problem. I think about it in hierarchical nature works the best, where you kind of look at it like it's these kind of children of each other or a chain that kind of goes down here, and you just want to make sure that they all line up perfectly. And so to do this, what we're going to use is a stack. And the reason why you want to use a stack is just the way that you push and pop from a stack. Whenever you pop from it, it's going to be popping in reverse order that you input it in. And so it just works really well where you're just going to push to our stack all the opening brackets. And then whenever you see that, okay, it's a closing bracket, you expect the top of the stack to have the corresponding matching opening bracket. And if not, you just return false. Okay, and so it just allows you to very easily perform that kind of reverse order popping of the stack using these closing brackets. So let's go ahead and write the code. So first thing is we're going to create our stack, and we want to return true if our stack is empty at the end of this program. And so we're going to want to iterate through every character in our string and handle two different cases. The first one is, okay, does this is this character a opening or is it a closing bracket? Okay, and so one thing that makes it a lot easier is if we just define a lookup table. And so we can say, okay, this closing bracket corresponds to this opening bracket. And we just want to repeat this for all of the three different types. Okay, and so this just makes it really easy so that you don't have to handle like the three different kind of switch case or like if-else statements in this program. So it's just a very easy way to quickly look up what you expect the matching open or closing bracket to be. Okay, and so if this character is not in this set of keys, then you know that, oh, I think I did this wrong. We want to make these the square ones. And these are the opening brackets on this side. Oh, I'm just gonna do that. There we go. So yeah, so the closing brackets are on this side and the opening ones are the values for these keys. So if our current character is not in our key, so not in the map here, then we know that, okay, this is a open parentheses. And so you want to just append to our stack. Otherwise, we want to process is a closing parentheses. And so in that case, we want to say, okay, if our stack's not empty and what's at the top of our stack, I'll just move me over here. We want whatever is top of our stack to be equal to the mapping of this current character. And so that's just going to convert the current character, which is a closing one, to the correct corresponding opening bracket. And since we're pushing these open parentheses to our stack here, we're expecting that the top of the stack has the matching like open parentheses for this current closing parentheses. Okay, it might take a little bit of drawing out to really fully understand that, but you just want that whenever you see a closing parentheses, what's at the top of the stack to have a matching open parentheses. And we can just easily translate it using this hash map. And if so, we can just pop from our stack. And otherwise, we know we just want to return false here. And that's just because, well, okay, if the stack's empty and we have a closing bracket, then naturally it's false. But then also if the closing and open parentheses don't match, then in that case, you also want to return false here. All right, and so that was successful for the test cases and submitted, and it was all correct. So the time complexity here is just O of n because you iterate through all the different characters in a string just once. This is finite, it'll only ever have 3, so it doesn't like scale with the input size, or it scales well, it won't like become exponential. It doesn't have anything to do with the space complexity really, so this is finite. But what does have to do with the space complexity is this stack here that we're using, which will be at most O of n. And so it's just an O of n time complexity and an O of n space complexity. So yeah, that was today's LeetCode problem. I hope it helped a lot, and good luck with the rest of your algorithms. Thanks for watching.